So we have a cylinder. So we have something like a piston in our car. Maybe not in our car. It's filled with 10 liters of gas, and the piston is put into it. The initial pressure of the gas is 109 kilopascals. Then the piston is pushed down, and the volume is 2.1 liters. So how do we do this problem? Yeah.
Maybe initial volume times initial pressure equals final volume and final pressure.
Good. Yes, this is the equation that we're going to use. What is a tip? How do you remember that? Do you just remember it, or what do you do to remember that?
I don't know. I kind of just remember it.
Okay.
Yeah.
So it just sticks with you?
Yeah.
Okay, any other tips to remember this is how to do this type of problem? Okay, so one thing that I do is I just go back to the ideal gas law, this PV PV equals nRT, and PV is, they're multiplied together. So if we have PV, then PV is going to be proportional to PV. So that helps me. Okay. All right, so then we have, this is liters, so that's going to be our volume 1. We have pressure 1. And we also have volume 2. So from this information, from this kind of story, we should already be able to know if our pressure 2 is going to be higher or lower. So for this problem, this pressure at the end, after we push on this piston, is the pressure going to be higher or lower?
Higher.
Good, it's going to be higher. So that's a good check. We can reason through that. It should be higher, and then we can check and make sure our number is higher. All right, so what I'm going to do is I'm going to solve already for P2, and then P2 is equal to 10 liters times volume 1. Oh, I'm doing it backwards, that's okay. Volume and pressure all over volume 2, which is 2.1 liters. Liters should cancel, and then our answer will come out in kilopascals. So we'll have to make sure that that's what it asks for. And then what number did you guys get when you did this?
519.
Okay, 519 and kilopascals. And then is this our correct sig figs? Yes, good. We need 3 sig figs, and this has 3 sig figs. So also remember to put that decimal there. Alex on the test is not going to tell you what number of sig figs. So as you're practicing this question in Alex, it will say 3 sig figs, but on the test, it's not going to say 3 sig figs. So you need to be thinking, make sure you practice thinking through that. How many sig figs do I need? Okay. All right, how is this problem? You guys feel like you could do this one? Good. So there is one like this on the final. If you are getting stuck on this type of problem, I would go back through and practice in Alex. Okay. All right, let's go to our calendar. All right, so we are here. We're on day 2 of chapter 12 notes. We have one more day of chapter 12. And then lab 5 is due on Thursday. Okay, so make sure if you haven't already turned in lab 5, that's the last day you can turn in without late points. And then we have our last lab. You guys will come on Tuesday. That's the last lab, lab 34. So be thinking about the pre-lab. Find a time to get your pre-lab done. And then Alex chapter 12 is also due next Tuesday. Be thinking about, so lab 34 and lab 5 are the last lab scores that are going on your lab grade. So make sure your lab percentage is where you want it. Okay, those are the last 2 on there. So remember, we have to have above 60% on labs to pass the class. So make sure you get those last 2 labs in on time. I'm going to try to remind us that we still have our signature assignment. So that is due on the day of the final. So I wouldn't put it off. You could put it off, but I would try to get it done as soon as you can. As soon as you turn in, I'll grade it. Okay. And then this, I wanted to bring this up. a few of us missed amino on the test, so if you missed that, I gave you back the points, but know that NH2 is amino. Amino does not have carbon in it, okay? So just like hydroxide, we have OH. The amino group is just NH2, okay? All right, questions about our...
What day is the final going to be?
The final is going to be the 17th of May. So it's a Tuesday. I don't have it on my calendar, but if you pull up the Canvas, you can see the rest of our schedule. So if we go to the Weaver State Canvas, we go to chemistry. So we have the April calendar and then May. So the final is the 17th. So our signature assignment is due the 17th, and the Pi progress is also going to cut off this date. So I would try to get it done before the final, because you don't want to be worrying about that when you're studying for the final. But that's when it's going to post on your grade. Yes?
Do you know what time?
I think it's midnight. Oh, the final? When is our final?
Yeah.
Our final is just during class.
I was just doing class.
Yep, and then you have 2 hours.
It's 40 questions, right?
Yep, 40 questions. Yep, so this final packet is like a template for the test. So if you go through and you practice these questions and questions like it, you'll be ready for this. Have you guys been using this, hopefully? Or you will think about doing that? Okay, we're getting really close, okay, to the final. All right, and then the final is 15% of your grade. So that could be good or it could be bad. So, all right, let me open our notes for today. So today we're going to talk about naming and how we name organic molecules. Let me just delete our notes from yesterday. I forgot that I should delete these. Okay, I think that's all of our writing. So we have a standard way of naming organic molecules, and we use this these rules. So it's called the IUPAC, and that comes up when you're talking about rules in chemistry. They come from this IUPAC organization, and that's the International Union of Pure and Applied Chemistry, and that's what we call them, the IUPAC. So I want to be able to name an organic molecule, and somewhere in Brazil, they're naming the same molecule, and we have the same name if we use this IUPAC naming. Okay. This word, nomenclature, just means that we're naming something. Okay, that's the IUPAC comes up with the rules so that we are all on the same page. We're all calling the molecule the same thing. And each of these names is unique because we're naming it based on its structure. And then as we go through these rules are on this note sheet that we got. So if you can write them down, that's okay, but it's also on this note sheet. Did anyone show up that needs this? We got this last time. So this is day 12 of chapter 9. Day 2 of chapter 12. Okay, so this is just an example of what's going on. So this is an example of a drug. So I usually call this ibuprofen. So that would be our generic name. We just call it ibuprofen. The systematic IUPAC name is this complicated. Ours aren't this complicated, but this tells us exactly the structure of ibuprofen. Okay. So we have 2 and then bracket 4, parenthesis 2, methyl propyl phenyl propionic acid. So no matter where you are, you would name it the same way. Okay. And then we also have a trade name. So all of these are talking about the same molecule. The trade name is somebody has come up with a way to synthesize this that's different, or they've come up with a way to crystallize it so it's more pure, or so it's the same molecule, but they've come up with a way to make it. And so they get to call it their trade name. So Motrin or Advil, that's also ibuprofen, that's also this molecule, okay? So today what we're gonna talk about is how to name it, some of these simple molecules using the IUPAC naming system. So this is how we name any organic molecule in the IUPAC naming system. So we have a prefix. So the prefix tells us what's attached to the carbon chain. And we also have our parent. So this is the longest carbon chain. We name it based on that longest carbon chain. And then we tell you what's attached and where is it attached. So if we have a methyl group at 5, we're going to tell you that in the prefix. And then the suffix is the functional group. So today our functional group is just, we're just talking about alkanes. So remember, alkane is just a carbon-hydrogen chain, just boring, nothing else. No double bonds, no triple bonds, okay? I think we're going to talk about if we have a double bond or a triple bond, we'll talk about what to do with the suffix next chapter, chapter 13. But we're not really worrying about that today. So these are the 3 things that we need to figure out before we can name an organic molecule. Okay, so here are our rules. So the first thing that we like to do is find the longest continuous chain, and this is what we practiced last time. And then we name it with ane. So if it's 5 is the longest carbon chain, then we're going to name it pentane. And then if it's octane, that means we have 8 carbons in our carbon chain. And then we number the atoms. We practice this too. We number the atoms in the carbon chain so that this first substituent has the lowest number. And we practiced that last time, numbering the carbon chains. And then we're going to name the substituents, and we have on our sheet, we talked about some of the substituents that we care about. So methyl, ethyl, propyl, isopropyl, and then we have some longer ones, but we mostly care about the ones from Alex in the gray box. So once we know what the substituents are and where they are, then we're going to order them. They're going to be prefixes. We're going to order them alphabetically based on their name here. So an ethyl group is always going to come before a methyl group because ethyl starts with E, methyl starts with N. Okay. And then remember that the carbons either are on the longest chain or they're a substituent. They can't be on both, so be careful about that. But also don't forget any carbons. Okay, don't leave off a substituent or at the end of the carbon chain. Every time we have a substituent, it needs its own number. So if we have 5 substituents, we're going to have to list 5 numbers because I need to tell you where those substituents are on the carbon chain. And then if we have 2 or more substituents that are the same, then we're going to use prefixes. So if we have 2 methyls anywhere on the carbon chain, then we're going to call that dimethyl. So we're going to tell you where they are, and then they're dimethyl, and then whatever the parent chain is. Okay. And this box is also on your sheet. So if we have 4 methyls, it's going to be tetramethyl. Or if we have 4 ethyls, it'll be tetraethyl. Okay. Questions so far? All right. Then we need to alphabetize. Oh, I think I said that. We're going to alphabetize our substituents. So, yep, ethyl goes before methyl and propyl. We need to use numbers that tell us where these substituents are. And then this is kind of tricky. If we have a number and then another number, so we have 2, 4, dimethyl, then we need to say 2, 4. Okay, so between numbers we put a comma, between a number and a letter we put a dash, and we don't leave any extra spaces in the word. So I think this is more helpful if we do some examples. So I'm going to do 2 examples, and then I have 1 example for you guys to practice, and then the rest of the time we'll just have time for looking at Alex. So this is a molecule, and we need to name it. So what we're going to do is the first thing we need to do is find the longest carbon chain. So if I look at this, it looks like this is our longest carbon chain. Okay, so then I'm going to look and I'm going to number it. So I'm going to try this way. 1, 2, 3, 4, 5, 6. So longest carbon chain has 6 carbons. What's that going to be called? What's our parent chain?
X.
Good, hex. Good, hexane. And then this is our functional group. It's just a carbon chain with no double bonds, no extra alcohol groups or anything like that. All right, but if I number it this way, I have 1, 2, 3. I have 2 methyls on group 3. If I number it this way, 1, 2, 3, 4, 5, 6. If I number it this way, I have 2 methyl groups on group 2. So this will reduce the first substituent. So I'm going to number it this way. So let's cross out that one. Yeah, this way. So I'm going to go this way. 1, 2, 3, 4, 5, 6. Okay, now I need to look and see what substituents I have. So I have CH3, that's methyl. CH3, that's also methyl. I'm just going to write CH3, oops. And then I have CH3 over here. So this is going to be methyl. And I have another methyl. Okay, so I have 4 methyl groups here. So that's going to be tetramethyl. So first I'm going to tell you where they are. So I have 2 at 2, so I'm going to write 2. There's 1 at 2. There's a methyl group at 2. There's a methyl group at 4. There's a methyl group at 4. And then I have a number, and then I'm going to put a letter, so I'm going to put a dash. So 2, 2, 4, 4, and then tetra. Oops. Tetramethyl. No space. I'm trying to take up the space. Tetramethyl hexane. So this would be the IUPAC name for this molecule. I'm telling you where all the substituents are. I'm telling you there's 4 methyl groups, and the parent chain is called hexane. Okay, questions on that? Okay, I'm going to do one more example, and then I'm going to let you guys try one, and then we'll just work. Okay, so here I think this could be the longest carbon chain, or something like this could be the longest carbon chain. So I'm going to try both of those. So if I go 1, 2, 3, 4, 5, 6, 7. But let me check this one. This one looks pretty long too. 1, 2, 3, 4, 5, 6, 7. Okay, so it doesn't matter. Also, if I look here, I have 1, 2, 3, 4, 5, 6, 7. This way I have 2 carbon group and a 3 carbon group. And if I go like this, 1, 2, 3, 4, 5, 6, 7, I have a 2 carbon group and a 3 carbon group. So this is a symmetrical molecule. It doesn't really matter what way I order it, or what way I number it. It's going to turn out to be the same. Okay, then also let's check. I like this way, so I'm going to stick with that. But let me check the other numbering. Let me try this. 1, 2, 3, 4, 5, 6, 7. So this doesn't matter. Both of my substituents end up at the 4th carbon. Okay. The longest carbon chain has 7 carbons. So what is the parent carbon chain? 7. Heptane. Good. Heptane. Good. So I'll put it down here maybe. Heptane. Okay, and we're using ane because we don't have anything special. Okay, and that's what chapter 12 is just boring carbon chains. All right, so the next thing I need to do is, since I'm numbering, this is our carbon chain, I need to name this side chain and I need to name this side chain. So if I have a 2-carbon side chain, what is that called?
Ethyl.
Good, this is ethyl. And I have a 3-carbon chain and it's attached by an end, not the middle. So what would this one be called? Good, this is propyl. Okay, so I have an ethyl and a propyl. So the first thing I need to do is alphabetize these before I can put them in. So which one would go first? Ethyl, good. So I'm gonna say 4, comma, oops, dash. This throws me off. So we have a number and then something different, we put a dash. So 4, ethyl, and then number and a letter. So someone in the last class said if it's different, you put a dash. If it's the same, so if between 2 numbers, you're gonna put a comma. Ethyl, and then we also have 4, propyl, no space, heptane. So 4 ethyl, 4 propyl, heptane. Okay, questions on that one? So, honestly, it's not too hard, but I would practice a whole bunch of these to make sure you get the reasoning and you get these rules. But it's once you've practiced, it kind of sticks with you. It's harder to forget what's going on. Okay, so here's one. It's drawn a little bit weird because I used the free chem draw, and so these hydrogens, I didn't want to do Photoshop, so this hydrogen should be up here if we're drawing it like Alex. So go ahead and try to draw, or not draw this, try to name this one. And then there are bonds here, they're just not shown. Okay, so what should we start with? Okay, longest carbon chain. What did you find was our longest carbon chain? Okay, straight across. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So what is that called? Good, octane. Okay. What's next? Numbering. Good. So should we number it like this? 1, 2, and have a methyl group, or should we do 1, 2, 3 and have a methyl group? Good. So this one is our first. So we go 1, 2, 3, 4, 5, 6, 7, 8. All right, and then we have some substituents. One substituent here. Here's one, and here's one. Okay, so what is this one called?
Methyl.
Good, methyl. And we have another methyl. And what's this one?
Purple. No. Ethyl.
Good, we've got 2, so that's ethyl. Good. Okay, so now we need to put our side groups as a prefix. So which do we put first?
Ethyl.
Good, ethyl goes first because ethyl starts with E. So we're going to put 5 ethyl. Okay, and then what will we do for methyl? We have 2 identical.
We do the 2, 6,
Good.
dash. Do we put di?
Good. Then we put dimethyl because there's 2. Perfect. Dimethyl, no space, octane. Okay, questions on that?
The hydrogens are just drawn on there.
Yeah, the hydrogens are just drawn on there. So if you go to ChemDraw, there's an online ChemDraw, and I just tried to draw an example in it. It wasn't. I don't know the settings on that. So it put the hydrogens below. Yes. Okay. Questions on that? Let me show you the ChemDraw really fast. So that's our last slide. So I have it bookmarked, but if you Google it, it'll come up. And then you can just start drawing, so I like to make it really big. And then, so if you are doing, if you're trying to talk about molecules in your signature assignment, this would be a good way to draw them. Or if you ever have to draw them or something. You can add a double bond, oops. Or I can make this one into an oxygen. Okay. It also has some cool stamps. So depending on what you're doing, or if you are in a lab and you're trying to explain to people what they need to use. So it has some cool stuff in there. Oops. Oops, I don't know what I did. Anyways, so that's what I've been using to draw some of our examples, but it doesn't always look like Alex. So, okay, so the rest of the time is yours. We have one more lab left. So if you haven't done lab 5, I would probably work on that. I would also practice this. This is something that you have to learn the logic, like learn the rules, learn how to do that. Okay, so I would practice some of these on Alex, work on your lab, work on the pre-lab. If you haven't done your signature assignment, you can do that. So we have lots to work on. So make sure you're using good use of your time.